Hey, good morning and good evening. Just wait for a couple of minutes. We'll get started. Uh, just one more minute. Okay. So sharing the screen. 1 second. Okay. Hope everyone are able to see the PowerPoint slide screen now. So in the initial demo session, we have learned about what is performance testing, LoadRunner architecture, how to record and replay. And yesterday we have discussed about different types of performance testing like load test, stress testing, endurance test, scalability test, volume test, and a kind of a spike test. Right. So yeah, I think there is one type of testing which is left over from yesterday. We will cover that today, but not immediately, with maybe in few minutes from now. So first we will discuss the importance of a software architecture. Okay, so let's say you have an application where you need to enter username and password and login. Okay, now as usual, as usual, you entered username and password and you logged in. Okay, ideal time is like 2 seconds or 3 seconds depending on the application, right? But let's say this login took 30 seconds. So it is successfully allowing me to log in and navigate to the home page, but it took 30 seconds to log in. Okay. Now, is that okay or is that not okay? That is 30 seconds okay for us as a performance engineer, or should we leave it? Or I mean, not from performance engineer perspective, from user perspective, is 30 seconds okay for login?
No,
No.
no.
That means there is something wrong, some issue in the login process. Okay, issue is not with the functionality, but issue is with the slowness. Now, when you enter username and password and you click on this submit button, uh, it is navigating to home page, but it is taking approximately 30 seconds, which is a kind of an issue. Now, as a performance tester, what we have to do here, because it is taking 30 seconds, we have to we have to find the root cause. Okay. So why it is taking 30 seconds? Okay. So of course, even if you convey the same to developer will also find the root cause. But we as a performance engineer, if you know the architecture, it is easy to find out from our side also. That means when you enter username and password and click on submit button, what exactly is happening? When you click on submit button, what exactly is happening in the backend? Where, I mean, the request is going to which server, and you know, what are the downstream requests that are going, and what are the, I mean, how the response is coming back. So we have to know that flow. If you don't know that flow, how will you find out the root cause? You'll not be able to find out the root cause, right? So when you click on submit button, what exactly is happening, you should know, correct? So then only you will be able to find the root cause. Now, when you click on submit button, generally what will happen? Okay. So I just mentioned those points in again here. So what if the login process is slow? Reason could be an issue with the application. Whatever the issues because of which this login process is slow is called bottleneck. Okay. To identify the bottleneck, we need to understand the architecture of the application. So what do you mean by understanding the architecture of the application? In today's example, you need to understand what exactly is happening when you click on submit button. Okay. So generally the request will flow to web server. From web server, it will go to app server. From app server, it will go to database server. That's a general process. But before going there, before understanding those terms, first we'll try to understand what is a server. This is a common term that we use in our day-to-day work assignments. So, and you might also have heard about this, people saying, hey, server is down, server is not available, server is too slow, it seems, something like this, right? So what exactly is a server? So when you click any link or any button, right, a request will go to the server in the backend like this. A request will go to server and the server will send the response. Now, a server is something which which should be able to understand what the client is sending, and once it understands what client is sending, server will be able to process the request and then send the response back. So anything, okay, anything that can follow these three steps: understand your request, process your request, and send the response back, can be a server. But software alone cannot run on its own, right? It also needs some hardware support. So uh, a kind of combination which can understand your request, process your request, and send the response back can be termed as a server. Okay. So you are sending something, it should understand, it should process, and it should send the response back. Okay. So you click something on the page and the request will go to server, it will process, and it will send the response back, and then the same response you will see it on the UI, right? So that's a continuous process. We click links, buttons and all, requests will keep on going to server and server will process it and send the response back. Okay, but only it will be able to process that request only if it is able to understand it. Okay, so all these 3 points are important. Now, generally in our project architectures, okay, you will see these kind of components. So one is a web server, other one is application server, third one is database server. Now, when you click a link on the client machine, okay, immediately a request will go to web server. What kind of request will go to web server? Like a HTTP, HTTPS request, right? So when you click on it, a browser-based request will go to server, right? It will initially go to the web server. So what is the role of web server here? Basically, web server is where the the website is hosted, right? So first it will go to that server, and then it will further go downstream. Now, what is a website? What is a web server? Where websites are hosted, something like that, right? Now, what is a website? Can anyone tell what is a website? In simple terms, website is nothing but a collection of web pages. So you have a lot of web pages. You click one page, it will go to another page. You click another page, it will go to some other page. Like it's a collection of web pages. Now this web server is primarily responsible for receiving the request from the client and forwarding it to the application server. Okay. So client, when you click any link from the client machine, generally a HTTP or HTTPS request will go to server. What kind of request will go, guys? HTTP or HTTPS request will go to the server. So from here, a request will go from here. So ideally it will be HTTP or HTTPS. Okay. And what are the examples of web server? Web server examples are um, Apache Tomcat, and you also have Microsoft IIS. Like generally, Microsoft IIS is mostly used for Microsoft related projects, technologies where they use this Tomcat. Apache Tomcat is used for any sort of application. No, I mean IIS can also be used. So these are primarily used, in most of the projects. So this request from web server, it will go to application server. This application server is very important. I mean, all three components are important, but this is where performance engineer will focus more. I mean, more on both app server and database server, but let's see what is application server. So whatever the request that web server is getting, it will simply forward it to application server. Like for example, a servlet request. Okay. If you are aware of Java, there is something called servlet request kind of thing. So this application server is primarily responsible for processing your request. What does that mean? It means the entire business logic will be resided in the application server. Okay, I repeat, the entire business logic will be resided in the application server. That means whatever the developers have written the code, all that code will be stored in this application server. Now, when you send some request to, when you click a link, when it reaches application server, it will execute the code, execute the logics. Okay, it will execute the code, execute the logics. So because it has its entire business logics resided, so it will run that, it will run those logics. Okay, so and then if required, it will it will connect with database server to fetch further data if required. Okay, not every request needs to go to database server, but some requests might go to database server if there is any database dependency, data dependency. Otherwise, application server itself will process the request and return the data back. Okay. So what are the examples of application server? Like you have a WebLogic, WebSphere kind of thing. Okay. You might have heard these terms, right? There are many others, but I just wrote uh, two. So application server is on the component where the entire business logic resides. That means where the entire code is stored, and this is responsible for processing the business logics, executing the business logics. Okay, and as I mentioned, this application server will forward that request to database server if there is any data dependency. Like I need to validate some username and password. Where are those username and passwords stored? They are stored in database server. So that's the reason they will go to database server and get the credentials validated. Okay. Now what are the, also database server is primarily responsible for storing the entire application related data. Okay, so the data keeps on increasing. Yesterday also we discussed about volume testing. In that type of testing also I mentioned the importance of database. Okay, so it is where the entire data will be resided. Okay, data will be resided here. Um, so what are the examples of database server? Like Oracle, SQL Server, right? Something like that. So database, since database server, since it is containing the entire data of the application, so it can be called as a data layer. Since the entire business logic and the code is residing in the application server, it can be called as a business layer. Since the web server is simply receiving the requests and websites are hosted and all, you can call it as a presentation layer. Okay, so presentation layer, business layer, database layer. Now, out of all these three components, can you tell me which components are most likely getting performance issues? Which components might be most likely getting performance issues?
App server and database server.
Correct, because that is where the entire business logic is resided and data is resided, right? So the time taken to process the business logic or validate the data or fetch the data, okay, from huge amount of database, it might take time, and we might see more performance issues here in these two layers. Now let's say um, now let's say uh, from client there are hundreds and thousands of requests, you know, going, so redirecting. Okay, so firstly, uh, there can be a huge load on the application server. Since web server will not do any processing, it will simply forward that, right? It will not do any processing, it will simply forward that. Now the business logic is resided in the application server. So so there is a high chance that it might take more time, or you might see some performance issues, slowness and all that stuff, okay, because of the application server. Now if you are sending thousands and thousands and thousands of requests, okay, sometimes one application server may not be sufficient, may not be sufficient due to its configuration. Okay, in that case, client or the development project lead will decide to increase the application servers or upgrade the existing application server. Anything is fine. Okay, so either they add additional servers, or they increase the capacity. Okay, so this is called instance. Also, this is called app server instance. This is called another app server instance, or you can call it as node. Okay, or you can call it as node or instance, whatever it is. But but we can have multiple instances of these in your projects if the load is more, and if they think that business logic is might face issues, then they will add up more instances of these in your project architecture. Okay, so when they add additional servers, it is called scale out. When they add additional servers, it is called scale out. When we upgrade the existing server, then it is called scale up. What is that called? Scale up. When we add additional servers, it is called scale out. When we upgrade the existing server, it is called scale up. Now, why do they upgrade? Sometimes due to budget issues, time issues and all, it's easy to upgrade the existing server, right, rather than adding. But nowadays, every project will have multiple server instances for sure. Why? If you have only one instance of this, and for some reason if it is down, that means your entire application is down. Yes or no? If there is only one application server instance, and if that is down, that means your application is down. But if you have multiple server instances, even if one is down for some XYZ reason, the other server instances should be able to handle. Okay. Okay. So very important thing is, most likely you will have multiple application server instances in your project for sure. Now you might get a doubt. Since database server is also holding huge amount of data, will there be multiple server instances? Um, Actually, there can be a backup instance of database server, but it's not like multiple server instances. It's a kind of a primary and secondary concept. So some few months in a year, one will be acting as a primary, and few months in a year other will be acting as a primary. Okay, but anyways, most of the times there will be primary and secondary for database server also. Okay, that means a kind of a backup. Whatever the data that we are storing in the database, primary database server, all the data will be synced to secondary database as well automatically. Okay, now uh, you might get it out. So what if one database server is not enough? So generally there will be only one database at any point of time. So only thing is, client will request Oracle team or SQL Server team to increase the capacity of the database. How? For example, if your organization is buying an Oracle license, which can store 10 million records. Okay. Now, if your project is about to store more than 10 million records, you just inform the Oracle team to upgrade the capacity of the database. They don't add few. They don't add one more or two more like that. They just simply increase the configuration or increase the capacity of the database to store more amount of records. Like from 10 million, they can configure the database to store up to 20 million records, 30 million records, like that, 100 million records, like that. Okay, so it all depends on how much data will be stored in the database for that project and so on and so forth. Okay, so these are important uh, terms that we need to remember, because every day in our project work assignments we keep on discussing these terms. So when you're doing a performance testing, you might see um, you know like let's say um, some issues, errors, or some slowness, or some kind of CPU utilization, more CPU utilization, more memory utilization. So all of those can be linked with these terms. Like you can say the server instance one, CPU utilization is 90%, which is very high. Okay, here two app server instances are there, right? So when you are monitoring the results or analyzing the results, we have to analyze the results of both the application servers instances here. So for instance one, we have to make a note: CPU utilization 80%, memory utilization 70%. Instance 2, CPU utilization 70%, memory utilization 75%, like that. Okay. So very, very important terms frequently used in our day-to-day work activities. Okay, so just let me go here. Okay, so in this diagram, before diagram, I mentioned that server is something where like from the client we send one request and the server should understand it and then process it and then send the response back, right? So it will be able to process only if it is able to understand, correct? Now, how will it understand? Client is sending something to server. How the server will understand? So like they both should communicate in a common language, right? For example, if two people are talking to each other, they both should communicate in a common language. Otherwise, it will be difficult to communicate, or the other person will not be able to respond. Okay, if I talk to you in German, and if you don't know German, will you be able to reply? No. So same thing here also. Whatever the client is sending, the server should be able to understand it. Then only it will be reply. Otherwise, it will not reply, right? So how the server will understand is based on the protocol. So whatever the client is sending to server, okay, it's all about the protocol. Protocol is nothing but some set of rules. Protocol is nothing but some set of rules. So depending on the kind of communication required between client and server, protocol is selected by the architect. Okay, so in general, textbook definition also says protocol is nothing but some set of rules. Okay, if both client and server follow some set of rules or common standards that this is how I will be sending data, this is how you will be receiving the data, this is how I will be understanding the data, something like that, some common rules. So based on that, a communication will be established. So some common protocols that we generally see are like HTTP, HTTPS. That's a kind of a browser-based request. So when you hit a URL in the browser, you see HTTP or HTTPS, right? That's a protocol again. Okay, and if the communication between client and server is all about transferring files, then the protocol that they choose is file transfer protocol. Or if the communication between client and server is all about exchanging emails, okay, then they will use a SMTP protocol, like simple mail transfer protocol. Okay, so like that there are many protocols uh, based on what type of data is being exchanged. So the protocols will be followed and defined by the project architect. So the project architect will only define what kind of protocol should be used for communication between different components in your project architecture. Okay, so hope everyone are clear. So yesterday we were discussing about the different types of performance testing, and that we did not discuss about failover testing, right? So if you don't have any questions as of now, I will explain you that failover testing, why it is important in the recent past and all that stuff. One sec. Okay. So yesterday we discussed about these types of testing and we did not discuss about this. So let's try to discuss this one. Now, okay, let's say this is a client from where the requests are being triggered. Let's say this is application server 1 and application server 2. I told you, right? There will be two instances. Now, in the project architecture, at some point, okay, at some point, there will be one additional program or a layer called load balancer. There will be some additional layer or a program, a kind of a program. It is also a program only, which we call as load balancer. Okay, this is client or let's say LG machines. In for performance testing, it is LG. Otherwise, it's a general client machines. So all the requests will be going to this. I mean, it will be configured in the web server machine or somewhere. Okay, this load balancer program will be configured in the architecture. So the primary role of the load balancer is to distribute the load equally. So let's say this is server 1, server 2. We discussed few minutes ago, right? Application server 1, server 2. So let's say so many requests are being sent from client to client. So there will be a program in between called configured in between called load balancer. Now, what is the job of load balancer? Since the architecture contains multiple server instances, let's say multiple application server instances, the request should be redirected accordingly. Like let's say one here and one here and one here, like that. Because there are two instances, right? Both of the server instances should receive the request. Then only it makes sense. Okay. Now, on what basis the data is being redirected from the load balancer? Load balancer has its own algorithms to follow. Again, which load balancer algorithm is used in your project? Again, you have to check with your development team. So they will be guiding you. There are multiple algorithms which we will discuss in our upcoming sessions, like round robin algorithm, weighted round robin algorithm, least connection algorithm, weighted least connection algorithm, like that. There are few set of algorithms based on which the data will be redirected to multiple server instances. Which load balancer algorithm is selected in your project, you can check with your development team. Okay, now everyone clear that there is something called load balancer program which is configured in your architecture, and its job is to redirect or distribute the load accordingly to different server instances. Correct? Till here everyone are clear? Now, what is this failover test? When you have multiple server instances in real time also, there is every chance that one of your server might be down for some XYZ reason. Okay. Now, keeping that in mind, in real time, there is a high chance that your server might be down, right? Then how the other servers are responding? That is, so to find out how the other servers are responding when one of the server is down, we will do a failover test. So to do this, so one day before or 2 days before only, we will inform the admin team and the dev team that we are going to perform a failover test, let's say Friday morning 9 a.m. to 10 a.m. Okay, so Friday morning 9 a.m. to 10 a.m. is what we want to run a failover test. So we will coordinate with the dev team and the admin team. We join the call with them. Okay, like few minutes before 9 a.m. we join the call and everything will be ready. And 9 a.m. the test will begin. Okay, normally we will send like whatever the load test volume is there, the same volume we will send. Keep on sending the requests. Then what is the job of load balancer? 9 a.m. start load test kind of thing. Okay. Uh, so the request will keep on going, and the load balancer will start distributing the load to server 1 and server 2 accordingly. So this will continue till 9:15, let's say. Till 9:15, let it be. See how the data is being distributed and see how server 1 is performing, how server 2 is performing, what is the current state, current CPU utilization of server 1, current CPU utilization of server 2, current memory utilization of server 1 and also server 2. You can monitor that. And suddenly at 9:15, ask the dev or admin to bring down one of the server, one of the server. Like let's say at 9:15 they brought server 2 down. Intentionally they stopped the server 9:15. Intentionally they stopped the server at 9:15. From 9:15, let's say till 9:30, monitor again. So what is happening here? 9:15 server 2 is down. That means there is only one server available, that is server 1. Now the good thing is the load balancer has the capability to know that if a server is down, it will automatically come to know in in very few seconds, like 2 3 seconds. It will come to know that one of the server is down and not receiving requests at all. Hardly in 1 2 seconds it will find out. It has that capability. Now when load balancer has the capability to know when a server is down, and here at 9:15 server 2 is down. Now what the load balancer will do, from 9:15 it will redirect all the requests to server 1 only. In this case, from 9:15 to 9:30 or 9:45, whatever it is as per your plan, see how the server 1 is behaving, because it is receiving double the load than expected. Okay, it is receiving the load from server 2 also, because it is down. All the requests that are supposed to go to server 2 are now coming to server 1 only. It is receiving double the load kind of thing. Okay, now from 9:15 to 9:30 or whatever at the time, mm, find out how the server 1 is behaving. What is the CPU utilization of server 1? What is the memory utilization of server 1? How the response times are coming now? Is there any performance degradation? Are there any high response times? Are there any errors? Are there any server restarts? What not? Everything you have to monitor in that server 1. How do you monitor? You can use any APM tool like Dynatrace, AppDynamics and all. Okay. So once you noted down all the metrics for some duration, then again ask the dev to bring the server 2 back to normal. 9:30 to, from 9:30, let's say, or 9:40, let's say you ran that till 9:40, something like that. 9:40 to, let's say, 10 a.m. Okay, at 9:40, ask the developer or admin team to bring the server 2 back to normal. That means this server 2 should be up and running at 9:40. So again, the load balancer has the capability to know if the server is up and running again. Since when it was down, load balancer had the capability to know. Similarly, when it is up and running again, the load balancer will have the capability. So load balancer, again, since it has the capability to know that the server 2 is now up and running, then immediately it will start sending requests to both here and here and here and here, something like this. Then again you monitor how the servers are behaving. Okay, now again when the load is being distributed equally among both the servers, verify how the response times, CPU utilizations, memory utilizations, errors, etc. Okay, so primarily failover test is done to make sure that if any one of the server instances are down or multiple server instances are down, then the remaining server instances able to withstand the load or not. Okay, to that's the main motto or goal of executing a failover test. Any questions? So everyone understood the concept of failover test? So in every project, there will be multiple server instances for sure. Okay, because one instance will not be able to handle all the load, right? If 1,000, 2,000, 3,000, 5,000, 10,000 people are accessing the same server, then what is the use? That server will be overloaded, right? That's the reason there will be multiple server instances. And just to make sure that if any one of the server instances is down for some XYZ reason, then are the other server instances able to withstand the load or not, is what we are verifying here. Any questions? Now, this is a little bit famous in the recent past because and most of the clients are aware of these concepts now, and they are insisting the performance team to run these type of tests as well if possible. Okay, it's not complex. It's just you need to coordinate with the admin or dev team. So just join the call with them, inform everyone that you're going to run this type of test today, and make sure you just note down the metrics and analyze it later. So so how much time, what are the response times when two server instances are up and running? What are the response times when there is only one server instance up and running? What are the memory CPU utilizations when both are running and then when one single server is running? Like, are there any errors in both the cases? So all these things is what you need to make a note of it. Any questions?
Yes. Who is responsible for turn on, turn off servers?
Uh, uh, in most of the projects, the performance team will not have access.
Mm-hmm.
Uh, I mean, in some projects we do have, like especially if it is a cloud based or any Kubernetes pods, containers, things. Generally, for stress environments, we do have access. If it is a specifically dedicated stress environments, I'm sure they might give us access to run on it on our own. But otherwise we need to reach out to the dev team or the admin team who owns the environment. So sometimes there will be a different team who manages the servers up and down, or most of the times, or maximum dev team will definitely have access. Most of the times they will assist us directly. In the recent past, I have been observing that in most of the projects, access is being directly given to the performance team so that they can work on their own without any dependency on other teams. Okay, so if you are
Which knowledge tester should have to work independent with servers turn on, turn off?
sorry, can you repeat the question?
I mean, which knowledge? For example, I don't know how to turn on, turn off servers.
Yeah,
How to get that
you
knowledge?
need you need to take the knowledge transfer from the dev team on that. So basically, it will be very simple UI. Nowadays, everything is UI based. Most of the times, like let's say if you are using some Kubernetes pods or something, you just go and click the down arrow button in their portal so that the server will be down, or there are very minimal one or two steps that you have to do to bring it down and or bring it up. It's not a big thing. Generally, if you can connect with your dev team for 5 to 10 minutes, they will be able to show you, and going forward you should be able to do it on your own. So it's nothing wrong in taking the knowledge transfer of these small things from the dev team. Okay, so that is our responsibility only. So we have to reach out to them and take as much as knowledge as possible. Since we generally, as a performance team, we try not to be dependent on other teams. So we generally, with the with the help of dev teams or admin teams, we take the KT of that process, and we own we own the responsibility of bringing it down and bringing it up, since it is a stress environment or testing environment. If it's a production environment, definitely we might not have access. Only specific team members will have access, because if you have access to bring down the servers in both production and testing environments, by mistake if you bring it down in the production, it will be a huge problem, right? So generally we do not have access to bring it down in the production. We have access in the test environments, which you can take the KT from dev team. Okay.
Yeah, thank you.
Okay. So I will give your okay, one more thing. So let me hope everyone are clear with this failover, so that I'm just removing this diagram. Uh, Actually, one more slide I just wanted to share today. So this slide is explaining or showing us the different phases of performance testing lifecycle. Generally, if you attend any interview, they will ask you a question. what are the different activities or tasks that you do in your project on day-to-day basis, or what is your exact role, what you do in your project. Okay, so the answer should be something like this. um, I mean, uh, I have I have work experience of or you can say something like this in simple terms. So in my previous project, I was responsible for handling the entire project, which means working in all the phases of performance testing lifecycle. So here, NFR is one phase where you gather the requirements. Test plan is something which you prepare which is nothing but like it's a kind of a roadmap for your performance tests. It will tell us what to do, when to do, how to do, a kind of a detailed roadmap. And you'll also have like another area called workload model, which we need to work to calculate pacing and all. We'll discuss that later. And we need to do scripting, we need to prepare our own test data, we need to prepare our own scenario design, we need to execute, we need to analyze, we need to provide our observations and concerns or recommendations. So all these are different phases or different phases of performance testing lifecycle. So every performance tester should be able to work in all of these, right from NFR till reporting and documentation. So your simple answer should be, in our performance testing projects that I worked, I know I had to work in all the phases of performance testing lifecycle, right from NFR till reporting and documentation is what you have to reporting and recommendation is what you have to say. So left side three, whatever you are seeing, non requirements gathering, test plan, workload modeling, and all, these are all document based, very important. And the right side, most of them are tool based, like scripting you use Vuegen, test data also you can use Vuegen and some other tools if required. Scenario design and creation you use controller or LRE, and analysis of course you have a separate component. So right side components or phases are tool based, left side are mostly document based. So we will see I mean what requirements we need to gather, you know what is workload model and all that stuff we'll see for sure in the next sessions. So this is the life cycle, or generally they will ask you what is the process that you usually follow in your project. And okay, so if you are assigned to work in any of the performance testing project, where exactly you will start? Will you directly start scripting? Will you directly start execution? No, you have to understand the requirement first. So our first step is always requirements gathering only. Okay, it could be any testing methodology like agile or waterfall or whatever it is. Our first work activity will be to gather requirements only, because without understanding the requirements you will not be able to deliver the project. So tomorrow I will we will discuss in detail what are the requirements that we need to gather, what information we need to gather from the stakeholders before you exactly start working on your project. Okay, so that is what we will cover tomorrow first thing. Any questions?
Regarding this test data, Kaushik, client will provide us, or we need to have our own.
Sorry, what is the question?
Regarding this test data, client will provide us, or how we will
Test
proceed with the
data.
test. Yes.
Test data is mostly the responsibility of performance engineers only. We need to know what type of test data is required. So how do we know? That is actually part of requirements gathering. So when we connect with dev team, so or business analyst, they will guide us on the application scenarios or flows. During that process, we will be knowing what type of data we need to create. So based on how the data is getting created from their KT process, based on how they are creating. Similarly, we should also try and create. So again, it's a responsibility of performance tester. Most of the times we create separate scripts for them for creating our test data. Let's say, I'll tell you one thing. So let's say you have a scenario where you need to cancel a movie ticket. Okay, the scenario is to cancel a movie ticket. Now this scenario of canceling a movie ticket, you need to run with 100 users for 10,000 times. Okay, 10,000 tickets is what you need to cancel in your load test. Then to cancel a ticket, what is the data that you need? Generally, in any normal case, if you want to if you want to cancel a movie ticket, what do you need?
First, we need ticket.
You need to have a ticket ID or a booking ID, right?
Yeah.
So that means if you want to cancel 1,000 tickets, 10,000 tickets, you need to have 10,000 tickets already booked. So that means in this scenario, your data dependency is to already have a 10,000 tickets booked. So we can create a separate script which is just to create ticket IDs. So once you run that script for some time, it will create a lot of ticket IDs. That ticket IDs list, we can take it and use it in our cancel ticket scenario as a test data. Okay, so like that, every scenario, if it is a data dependent scenario, we need to understand what type of data we need to send and create it accordingly. Sometimes we might need the help of some other teams also. We will coordinate with them in your projects and get the data ready. Sometimes let's take any, it's a banking application. Sometimes some data will be strictly available by from the other teams. So we need to in that case we need to rely on the other teams, but our part is to clearly send an email like 10 days before or 15 days before itself. You need to clearly send the information or requirement to them that, hey, let's say Jan 31st is a planned load test date for us, and we need 10,000 data of these loan numbers. Okay, let's say the scenario is to close the loan. So to close, so customers will take the loan, and you need to close 10,000 loans. Let's say that is a scenario. Loan closing is a scenario. Now to close a loan, you need to have some 10,000 loan numbers. Let's say that process of creating a loan number is complicated and we will not be able to do it on our end. There is some dependency. In those kind of cases, we need to reach out to third party teams or other teams who are responsible for it, who will guide us, who will guide us on that. Dev team will guide us on from where to get the data, which team will provide it, so that we can contact them. But but important thing to remember is, in those cases you need to reach out to them before itself. You cannot reach out to them 1 day or 2 days before the load test. Okay, we should give ample time, like 10 days, 2 weeks, at least 1 week time we need to give to them, so that they will also have some bandwidth to support us. Okay, any questions?
Okay, good.
Could we test that scenario when we download tool?
Yes. We have a lot of scenarios like that. So I mean, because you asked the question, there is one scenario, uh, like there is one scenario, or not scenario. Let's say the load test is something like this. You have two scenarios. Okay, you have two scenarios. One is book a movie ticket. Second one is cancel a movie ticket. Now you need to run both in parallel. But the thing is, for cancel ticket, you need to provide the booking ID. Then only it will cancel. So what we will do, we will run both in parallel, and we will start the we can create our scenario in such a way that we will start the book ticket just 2-3 minutes before the cancel ticket, so that it will at least create 1-2 tickets fast. Okay, and whatever the ticket it creates, it will transfer that ticket ID to the other scenario, right? Like this data can also be transferred from one scenario to other scenario, okay, by using some tools like VTS, or you can also write down that data to some file and you can read it from other script. So these kind of scenarios also we are going to do practically.
And one more question. Do we need to test for load, perform some load or performance test for example, for messages that you send? You said system will send like 2 weeks in advance to some event.
Mhm.
Do we need to
uh,
test those messages for load?
uh, E- e- I mean, yeah, kind of. For example, I mean, so what I understood from your question, correct me if I'm wrong. So what I understood is whatever the data we are getting from the other teams, should we validate it before using is what you are asking?
No. For example, I don't know, tickets.
Mhm.
Tickets bought like 1 month ago, and the requirement of the system is to send reminder email, for example, to the client who bought the ticket 2 weeks before event, that it's a last day, for example, client could return the ticket, um, something like that. All those messages from the system about some reminders for clients' actions possible after that day. Do we need to test it for performance?
Not required. Not
No?
required because we, I mean, it is, so those reminders are not going to cause any performance issues. Okay. So our performance issues will come only when our system is involved in it. What do you mean? What do you mean by our system is involved? When our application server or database server is involved in it, then there is a chance of performance issues. I think sending out a reminder or an alert will not have any impact on the application servers or database servers. So it's a simple alert based on some condition. There are many tools also, like you have some tool like login site, which is something external, and generally alerts are configured based on that tool, and it's not mandatory, or the load will not be on the application, our application for sure. So the alert generation or alert messages generation tool or utilities are there, which you can access externally and test it. But it's not, it will definitely not cause any performance issues, and it is not a critical scenario for us to test. We can ignore those.
Okay, got it. Thank you.
Okay. Yeah. So and I mean, because you mentioned that in our upcoming sessions, we'll also discuss what are critical scenarios and what are normal scenarios. Performance engineers will primarily focus on critical scenarios. So we need to work with business analysts and determine what are critical for business, and only those critical scenarios will be considered for performance testing. Okay, not all scenarios. So if you don't have any questions further, I'll give. Yeah, okay, it's already 9. Okay, so I'll be stopping the recording here for today. So we will continue tomorrow. So hope all of you got some information about different topics that we discussed. So all these are very very important, and they will ask you in the interviews also. So I mean, in general, whenever we discuss any topic, mostly I will try to explain the interview questions from the same topic every day. So that means for every topic that we complete, so we will also try to discuss the interview questions from now on. Okay, thanks everyone. I'll stop the recording here.
Thank you.